Hi, and welcome to this edition of Stats Chats. Here we are going to discuss how to create or how to analyze data in IBM SPSS Statistics using an independent samples t-test. For the data set we're using, we have surveyed a group of voluntary participants who participated in an empathy development workshop, and we measured attachment-related anxiety before and after participation in the empathy development workshop. And we want to see if there is a statistically significant difference between the treatment group and the control group with respect to attachment-related anxiety. Recall in the attachment literature, attachment style is like relationship style, and secure is the most optimal style. And so ideally, with a secure style, we have low levels of attachment-related anxiety and low levels of attachment-related avoidance. So we wanted to see if empathy, which is simply defined as feeling with another person, enhancing people's capacity towards empathy, could help reduce attachment-related anxiety. So let's take a look. First, we navigate to SPSS. So if you don't have the program open, you can navigate to the lower left-hand corner of your screen and click on the Windows icon and type in SPSS. As you begin to type, you'll notice that IBM SPSS Statistics auto-populates. You see the blue icon and you can click on the link and open the program. I already have the program open. So we can, once we're in the program, hope you're ready to roll up your sleeves and do some calculations, we can click on Analyze, and then when we click on Analyze, a drop-down menu appears, and because we want to compare the means between the two groups to see if there's a statistically significant difference, we're using the hypothesis of difference rather than association. So we go down, we scroll down to Compare Means, mouse over that, and yet another drop-down menu appears, and then we scroll down to the third option, which is Independent Samples t-test. And here, if you haven't done this before, these variables will not be loaded. So you want to scroll down and find the post-test variables. With this particular data set, we're going to use the variable of attachment-related anxiety at the time of post-test for the test variable. And then we're going to use the grouping variable, which is treatment group or control group. For the grouping variable, we need to define the groups. So 1 is for treatment, 2 is for control. We click Continue, and then we click OK. All right. Instantaneously, SPSS produces this output for us. And we can see, starting here, the t-test, here's the group statistics. So right away, we want to look at the N value. We can see that there was 30 participants in the treatment group and 20 in the control group. We can see that the mean ECR score for the treatment group was 2.23, and the mean for the control group was 2.86. So the control group had a higher level of attachment-related anxiety. We can see some other measures, including standard deviation, standard error of the mean. Then we go down to the independent samples t-test. The output here shows Levene's test for equality of variances assumed. So the first thing we want to do is test our assumptions. So we want to see can we assume equal variances? So Levene's test is greater than 0.05. It's only 0.053, so it's only 0.003 greater, but it is larger than 0.05, and it's meant to be a dichotomous. It is statistically significant or it is not. So it is not. So we can assume equal variances here. And so we go over, so we use the first row because Levene's test was not statistically significant. And we can see that we use the significance level for a two-tailed test. Here it is 0.04. This is less than 0.05. So we note that there is a statistically significant difference in attachment-related anxiety between the treatment group and the control group. And so if you look back, previous tutorial, we had created some charts, and I'm not sure if I have access to them at the moment, but if you look at the charts can give you an idea of what this looks like. So for example, this is the distribution for the scores for the treatment group. And you can see it's more leptokurtic. The peak of the curve is here, and its skewness and kurtosis values are less than plus or minus 2. So we would say it's a normally distributed, very slight skew here, positive skew, as you can see because the tail tells the tail. But the measures of central tendency are all clustered here around the middle. And if we look at the control group, here we can see it's more platykurtic, and we see that the curve is flatter, still a little bit tail slightly extended to the right here for the control group. So it's just a broader skew there. Right. So that is how to conduct an independent samples t-test in SPSS. And again, looking at the output, you want to look at Levene's test for equality of variance to make sure equal variance can be assumed. Now, if this was less than 0.05 and we concluded that there was a statistically significant difference between the variances for the group, then we would have to go down to the next row, equal variance is not assumed, and use the values associated with that outcome of Levene's test. Hope this is helpful for you as you create independent samples t-test. Thank you for taking the time to watch this tutorial.